Upload your doubts on the app to get video solutions.
A uranium-238 nucleus initially at rest emits an alpha particle with energy E. The recoil speed of residual nucleus thorium-234 will be which of the following, right? So what is happening here is basically, let's start with this. So here you have a uranium-238 nucleus. So this is uranium-238 and it is getting splitted, okay? It is getting splitted. Let's say it is getting splitted into thorium here. Let's say this is X, okay? This is 234, okay? X is the symbol for, I am just assuming that symbol for thorium is X, okay? And the mass number is 234. And one alpha particle is taken out. So helium here, and here it is 2 and here it is 4, right? This is our atomic number and the mass number of helium atom, alpha particle basically. So let me just write here alpha particle, right? Now, let's assume that mass of each nucleon here is M. So for each nucleon, let the mass is M. So let me just write here, let the mass of each nucleon is M. Fine. So we know from law of conservation of momentum, hence from law of conservation of momentum, what do we know from law of conservation of momentum? The initial momentum of the system must be equal to the final momentum. So Pi must be equal to Pf, correct? So if initial and final momentum are equal, so how do we find momentum? The momentum is found using mass times velocity, right? So 238 is the mass number, right? So 238 into mass number into mass of each nucleon, so M. And what is the initial velocity? If you read the question carefully, it is at rest, right? So initial velocity will be 0 over here, correct? And that will be equals to momentum, final momentum. So final momentum will be contributed by whom? One will be from this and one will be from this, right? So final momentum is contributed by thorium atom and alpha particle. So here it will be 234 is the mass number multiplied with mass of nucleon M. And what is the velocity? We will write it as V, correct? Plus, what is the next mass number? Mass number for helium atom or alpha particle is 4, and that multiplied with mass of nucleon and multiplied with velocity, let's call it as V, okay? That's the velocity of our alpha particle, correct? So this is our, let's say, equation number 1 for, okay, for the time being, let's assume this is our equation 1, correct? Now, if this is our equation 1, let's move to the other side and let's see the remaining part of the solution over here. Okay, so we know that kinetic energy is nothing but P square by 2m, right? Where P is the momentum and m is the mass of the particle. So kinetic energy is P square by 2m, and here the energy is kinetic energy only because that is moving, right? The particles are moving. So here E will be equals to P square by 2m because the energy here is given in the question as E. Okay, and what is P? P is nothing but mass times velocity. So we can write here E is equals to m square V square upon 2m, right? We can cancel out one of the m and we can write V will be equals to under root 2E upon 1m is left. So 2E, correct? So if the energy is given, as the question is saying, let's read the question once again. As per the question, it is saying that the alpha particle has an energy of E, right? So we can express the velocity of alpha particle in terms of E and substitute in equation 1, right? So let's recall equation 1. So equation 1, left hand side is what? 0. So let me write over here only 0. And right hand side, what we left with? We left with 234 into mass of each nucleon into velocity V plus 4 times m times V. Small v is what? That's the velocity of alpha particle, right? And that we can express in terms of energy, correct? So here it will be 4 times root under 2e whole divided by, what is the mass here? Mass of the nucleon. And how many nucleons are there here? In case of alpha particle, 4, right? So that will be 4 times m. Why 4 times m? Again, once again saying mass number. Mass number here is 4, right? So it becomes 4m. Now let's take this 234 mv on the left hand side. So this will become here minus 234 mv, and that will be equals to how much? 4m root under 2e upon 4m. For the time being, I'm just keeping it like this. Later on, we will cancel out things and we can make it much more simpler. Correct? So minus 234 mv equals to 4m root under 2e by 4m. Correct? Now what I'll do? Now I'll take everything on the other side and find the v, capital V. Right? So let's figure it out. So I'm writing it on this side. So let's take everything on the other side. So v, that will be equals to this m cancels with this m. Okay? And we left with 4 upon, let's keep it negative sign on the other side, 4 upon 234 root under 2e upon 4m. Correct? I hope this is clear. So we can take out the m by just rationalizing inside, or we can keep it like this also. Okay, 4 upon 234, this will be root under, let's just take this, cancel out this 4 with this, this 2 with this 4, right? Okay, so we can make it, or otherwise we can take that 4 inside also and we can cancel it out. Okay, leave it. So it will be 4 upon, this will be v equals minus, dividing 2 with, that will be 2 upon 117, and root under, we left with 2e upon 4m. Correct? Let's take this denominator 4 outside. Okay, so when you take the denominator 4 outside, what will happen? Yeah, this will simply give you 2 here. So let's write here 2 and keep them like this. So let's cancel this 2 with this 2, and our v will be equals to minus 1 upon 117 root under 2e by m. Where the negative sign, what does this negative sign represents? The negative sign represents here the mass. Okay, sorry, the negative sign represents here the residual or the alpha particle is opposite to the actual, okay, uranium-238, the opposite in direction. Okay, that's the negativity representing. And if m is 1, for m being 1, for m equals to 1, v will be equals to minus 117 root under 2e. Correct? So this is our final result. Let's see if there is such option. Correct answer is option C.
Watch the complete playlist on the app Pions. Download the app now.